I've been absorbed in work. Haven't any other states, have they reported in?
I'm pretty sure it's still, the same as it was yesterday.
They haven't? Okay.
Waiting on Nevada and Georgia.
Yeah.
There's still no news from Nevada yet. Okay.
Nope.
No, but they counted some more votes this morning, and Biden's lead got larger.
Yeah.
Oh, awesome. All right, so we are in the module. It says logarithm functions. We're going to spend most of our time today, though, finishing up simple and compound interest. But I want to do the practice quiz. So let me have you start with these first two problems and the practice quiz. All right, so three to the third, although my brain wants to call that 9, that's 3 times 3 times 3, which is 27, and 9 to the 1/2, my brain wants to call that 4.5, but that's not what it means. These two things are warring with each other. The 1 is the exponent trying to make the 9 grow. The 2 is working in the opposite direction, trying to make it shrink. So the bottom number comes out as the root. It's the square root of 9, which is 3. And then do part C. Okay, this one is a negative exponent does not give you a negative result. It's not going to be -8. As we mentioned before, it's like repeated division rather than repeated multiplication. It's like dividing by 2 or 3 times. Gives you 1/8. Alright, so for these first 3 problems, I have a new protocol. Since this is new for me too, I keep changing things up. But I realized I needed to get this number 4 in here, so I changed everything else. So when you give me feedback, rate the problem as a review activity. Number 1, I really have this down. Reviewing this type of problem is no longer necessary. Number 2, although the problem wasn't difficult, periodically reviewing this reinforces the concepts and the procedures. Should be yes. And then I needed this review, and it increased my understanding of this topic. And number 4, I still don't understand this. So, and then also I'm going to ask you to write something, reflect on what was gained by this activity. Now, you get to pick whether you want to talk about all 3 problems in general, one specific one of these, and however you want to do that. And go ahead and give me that feedback and hit enter. Okay. And do D and E. Well, D, E, and F. Thirty seconds more. All right. So on D, the bottom number comes out. Like this. Top number stays, trying to make it get larger. But I can change the order. Because I'm going to have the cube root of 64, which is kind of hard for me. I can shrink it first and then expand it. Doesn't matter which order you do it in. Cube root of 8 is 2. 2 squared is 4. Negative exponent. Bring it down to the bottom. It's 1 over 5 squared. 1/25. And when it's negative and a fraction, personally, I always take care of the negative first. Then I turn it into bottom number is the root. You can delay so we can make it smaller first. Delay this one so that it becomes smaller numbers to work with. Okay, on these three, give me feedback again, and let me show you the protocol again. These four. Go ahead and hit enter. Oh, and let me also say, you can give me fractions. Fractional E still confuses me. Something else. Right, let's okay. So if it was 5 to the second, it would be multiplying by 5 2 times. 5 to the negative 2, we discussed last time, we can think of it as dividing by 5 2 times. It's the same as multiplying by 1/25. Alright, this all is a foundation that we need for these. Make a quick sketch of these two functions. So you don't have to plug in points. If you have to, you can plug in some points, but if you know the shape of those curves without plugging in points, that's all I really need you to do. Okay, 20 seconds more. So on A, we know this is our standard parabola. On B, a couple things that are different about this. It doesn't go down to the origin. It goes down to 1. And then to the right, it's going to look a lot like that one, but it actually rises up a lot faster than this one. We talked about this when we did the exponential functions. Exponential functions grow way, way, way faster than x squared does after a while. But they kind of look kind of similar from this perspective. And the other thing, on the left side, is totally different. Instead of going back up, it gets closer and closer to the x-axis without touching it. The x-axis is what we call a horizontal asymptote. So it looks like that. And give me a little feedback on these two. Go ahead and hit enter. Okay. And a brief comment I want to make on the left half of both of these. Why is the left half always positive? Because when you take a negative times a negative, you get positive. Why is the left half way close to the x-axis? Because you're getting smaller and smaller fractions. That's why you get closer and closer to the x-axis. And then let's go to C and D, and I'm going to alter D. Let me change this. Okay, go ahead and do C and D. Thirty seconds more. All right, on C. It's going to be much like this other one. It's going to go through a height of 1. Why does it always go through 1 instead of 0? It's because when the input is 0, Oops, there's supposed to be an X there. You get 3 to the 0. Anything to the 0 is 1. That's why you always get going through the same thing. The only difference between this one and this one is this one rises faster. And it shrinks faster on this side. Because when you get to -1, you wouldn't be at 1/2, you'd be only at 1/3. When you go to +1, you're going to be up at 3 instead of a height of 2. So it rises faster and it shrinks faster as well. But it still has the same basic shape. Both of these have the same basic shape. And then, we had talked about this before. One problem that I didn't put in there is if I put y equals 1 to the x, well, that just looks like this. At a height of 1, it's always staying the same. So, when you have 1, it's a horizontal line here. But no matter what you have, if it's just something to the x power, you're still going to go through 1. But as the x gets bigger and bigger, you keep shrinking your output. It becomes half the size of what it was before. And then another half the size. And so on. And now to the left side, it's going to go up. And this, by the way, is the same thing as this. Why is that the same thing? Because 2 to the negative x, bring this to the bottom, 1 over 2 to the x, but 1 to any power is still 1. So that original and that are the same thing. Alright, so C and D give me feedback. And again, like for instance, if you're at like, boy, I really needed this review, but you know, there's parts of this I still don't understand, you can give me a 3.5. Part of it, you're one category, part of it you're in another. Go ahead and hit enter for your feedback. So, 1/2, by the way, is the same as 2 to the negative 1 power. So, that 1/2 in there is already a negative exponent. And now let's go on to E. Draw a quick rough sketch of that one. Okay, 20 seconds more. Alright, so what I know is that the x-intercepts are when x is 2, I'm going to get 0. When x is negative 1, that'll force it to be 0. And when x is negative 4, it'll force the y to be 0. So all these points -2, -1, -4. Okay. Now, each one of these is going to cross, not touch. Remember, y equals x squared touches the x-axis. When it's an even power, you get touching. When it's odd powers, these are all to the first power, we're going to cross. The end behavior well, if you pretended you FOILed all this out, just enough to get the first term, it would be 3x cubed. X cubed functions are like this. And if it was a negative sign, it would be opposite. On the left it would be up, and on the right it would be down. So I'm going to put all that information together. This on the far right's going up. I know it couldn't have turned and gone down because it would have had to have made another x-intercept. Between here and here, it had to have gone something like this. And then we're going to cross, and then we're going to cross again, and go down. And we get that end behavior, we get this. Alright, so that's E to F now. All right, 20 seconds more. X-intercepts. 0, 1, and -3. all of those will force the y to be 0. And this one, though, is special. It's going to touch. Because that 0 is of multiplicity 2, odd multiplicity. And it's going to just touch the x-axis. The other 2 is going to cross. So, the end behavior. Imagine foiling all this out. There'd be 1, 2, 3, 4 x's. So that's x to the 4th. It's only the leading coefficient that determines the end behavior. Leading term and leading coefficient. X to the 4th means both up or both down. Since it's negative, it's both down. So we're going to put that together over here. So at 0, let's make our scale. At 0 and 1 and negative 3. And then it's down. Now this one, I'm going to put a little, no, it's this one. I'm going to put a little t kind of nearby. Remember to touch. Now, if I crossed this, I'd have to go up, because if I came back down again, I'd make another x-intercept. There's no more x-intercepts. So, this forces me to get the right end behavior. Just touch it and go back down. All right, give me a little feedback on E and F. And again, here's the protocol. And go ahead and hit enter. Okay. I like the way you're giving me slashes or E and F and so on. That gives me separate information. Good. And all right, let me close those, open it up again. All right, number 3. If $600 earns 4% interest, what's the total amount of money after 1 year? Do this the fast way. Ten seconds more. All right, the total amount is going to be in one step 1 plus 0.04. Now, I don't have to put the plus sign, I can do 1.04. The idea is that when you distribute this to this, it gives you your principal back. When you do this, it adds the interest. It gives you your total answer in one step. And I'm going to pull out my calculator. I get $624. Alright, now we're doing number 4. $250, or 6% interest. Total amount of money after 20 years. Thirty seconds more. All right, 250. 1.06. Now that would give me the total after 1 year. And then I multiply it by another 1.06 to get the total after 2 years. Multiplied by another 1.06. Each time it would return the principal from the previous year and add 6% interest. And I do this 20 times, and it raises this to the 20th power. And then you got to be proficient with the calculator. I do the exponent part first. 1.06 raised to the 20th. Get a result. Multiply that by 250. And I get, rounded to the nearest cent, equal $801.78. Okay, give me feedback on numbers 3 and 4, please. And go ahead and hit enter. Okay. All right, that review part, even when you know something and you do the review, there's a name in educational research that they give that. It's called retrieval practice. And when you keep retrieving regularly, the way the brain works is your memories and your skills, and they call it use it or lose it. The brain actually takes the neural pathways that you're not using and chops them off, gets rid of them. It's only the ones that you use that it reinforces, and it's got to keep reinforcing it, or else it'll just disconnect it after a little while. And so that's a really important part of this learning process, is exercising our memory with these retrieval practice. All right, now these last two problems were sending us into going back to simple and compound interest. And before I go back into simple and compound interest, though, we never really answered questions on 6.1, or there might be some other questions from previous stuff. Anybody have any questions? All right, if no questions, we're going to go back and finish simple and compound interest. And I need you to go into your group chat, and group 3, remember you are moved over into group 4, so you should be in group 4 now. There's no more group 3. Everybody type in hi. Group leader, remind who the spokesman for the day is. Let's just get a quick count off. Group 1, how many of you are here? Group 2, how many are here?
All 4 of us are here.
Group 4? Anybody here in group 4?
There's 3 of us.
Yeah, there's 3 of us.
Okay. Group 5?
3 of us.
And group 6?
There's 2 of us.
Okay. And, alright. So, where we finished up before was kind of like what we did with these practice quizzes. 2,000 earns 3% interest. What's the total money after 30 years? And we had those. Alright. Now, here's where it starts to get important and a little bit tricky. 5A. Find the total amount of money after 1 year if $100 is invested at 6% yearly interest, compounded semi-annually, which means compounded twice per year. Now, this has got information that I haven't really defined. I haven't told you really what compounding twice per year means. But very important that you take a guess on this. Because when you see it, if you can relate it to something that you've guessed on, it'll be much more meaningful. So, make a guess as to what you're going to get for your answer, and enter it into your group chat. Type it into your group chat, but don't hit enter quite yet. Wait for my feedback. Okay, hit enter into your group chat. Look at what others have put in. You can discuss it briefly. Okay, group 1. If you've got more than one answer, tell me all the answers that you've got. Oh, not group 1, sorry, group 2.
We only got one answer, which was $112.36.
And whoever came up with that answer, can they explain how you came up with $112.36? This is a cool answer.
What the 2 of us that did come up with that answer said, or what we did was we multiplied 100 by 1.06 squared, because the interest isn't added just once per year, it's added twice because it's semi-annually, which means it's as if you added 6% for 2 years normally.
Very good, very good. Now, this is what I would have come up with had I been asked the same question in your shoes. I would have said probably exactly the same thing. It turns out that this is way, way, way wrong though. And I would have been way wrong on this. And let me tell you what's way wrong about this. This is what we call an effective interest rate of 12.36%. Because $100 turned into $112.36. Effectively, it was giving you over the course of 1 year 2 years worth of interest, 12.36%. And if banks did this, they would quickly go out of business. How does a bank survive and make money? Well, it survives and makes money by giving people interest on money that they deposit. So if somebody deposits money, they might give them 2% interest. And then somebody else wants a loan, and so they loan it out at a higher interest rate. Then, so they're, yes.
Mr. Shankin, I think I know what the correct answer is.
Go ahead.
$106.09.
You're changing it now. $106.
And the reason being is because it's 6% per year, not 6% per half year. So what you do is you say 100 times 1.03, and then you multiply the answer from that times 1.03.
Very good. Very good. This is going to be the real answer. And because what happens is you're not entitled to your full 6% interest after half a year, because you've only given them their money for half the time. So you're only entitled to half your interest at the halfway point. And so this turns out to be an effective interest rate of 6.09%, and banks can do that. They'll say, hey, we got a great deal, we'll give you 6%, compounded twice per year, and they're just giving you a little bit more than the 6%. They can handle that. All right, so let's go through part B, the contract. I will let the bank hold my $100 for a full year, and they will give me 6% interest. After 6 months, have I fulfilled the entire contract? Well, no. What fraction of the contract have I fulfilled? Well, I only let them have the money for half the year, so I've only fulfilled half my contract. Since I've only fulfilled half my contract, what fraction of the interest is owed to me? Half of it. They give you half of your interest at the halfway point, and then the other half of the interest at the end. So we're going to fill in the following chart. This is if I was live, I'd be writing on the board, but give yourself only half the interest after half a year, and the other half at the end of the year. So at the halfway point, I get half of the interest. So notice I'm not dividing the 1 by 2. I'm not cutting my principal in half. I'm just cutting the interest portion in half. And this is 100 times 1.03. Move the decimal 2 places to the right. It's $103. So at the halfway point, we have $103. Now, at the beginning of the second half of the year, we start out with $103. Because that's what we ended the first half with. And then undo the other half of my interest. Cut that interest rate in half, because only another half a year. So it's 103 times again 1.03. When you punch this out on the calculator, you get this number 106. Let me just double check that on the calculator. That sounds right though. 103 times 106.09. Alright, now, one of the questions I might be asking at this point would be, where in the hell did this 9 cents come from? And the 9 cents came from half a year's interest. Interest on the $3. At the halfway point, you didn't start with $100, you started with 103. That extra $3 also earned interest, which was a measly little 9 cents, but that's how compounding of interest within a year goes. Compounding more than once a year is going to get interest on some interest, and you'll get these little extra cents. And banks can handle that no problem. All right. Any questions?
Mr. Shankin, I have a question. Where did you get 103 and then I'm just confused where you got that one.
Where I got this middle entry, the 103?
Yeah.
Okay, let me go over that again. So we start with $100, and we only have the money in for half a year. So when you distribute this times this, it's going to return the principal of $100. When you take this times this, it's going to add your interest. But we didn't have it in for a full year, so we're not entitled to the whole 6%. We had it in for half a year, so we divide that interest 6% by 2. So 1 plus 0.06 divided by 2 is 1.03. 100 times 1.03 is 103. Does that make it more clear?
Yes.
Okay. Any other questions? All right, let's take a break now. And we will start again. At 1:36 p.m. in 15 minutes.
Before you go, Mr. Shankin, I just
Yeah.
had a quick question.
Yeah.
We can discuss at the end of class too, but I need to make up the exam.
Okay, and your name is?
Lydia Steinhoff.
And you had talked to me beforehand.
Yeah, I emailed you.
Yeah,
I had
yeah.
internet problem.
That's right. So
Tuesday.
yes, let's talk. Let's talk after class, so that
Okay.
we can talk with a little bit of privacy. And so after I close out this live feed, I'll open up a new one, and then you
Okay.
join that, and then we can talk. Okay,
Okay,
and
perfect.
you might have to remind me. I have a bad memory for things like this.
All right, will do. Thank you.
The exam that everybody took, I am still in the process of grading those. So most exams have not been graded yet. They'll be over the weekend that I'll be grading those. It's slow because of my vision difficulties. Okay. Anybody else need to speak with me individually? All right, I'm taking my break as well. Okay. Okay, let's start again. Destiny, you have a question. Is it for the class or for me individually? Maybe you're not back from break yet. Let's go.
It was just for you.
For me? Okay.
Yeah, it was just really quick.
Uh-huh.
It was just super quick if you got my test.
Oh, did I receive your test?
Yeah.
Yes, I believe so. Yes.
Okay. Because I had some technical difficulty with that, so.
Okay, yeah, no problem.
Cool, thank you.
You're welcome. So, let's go back here. Let's complete this last chart again, but this time we'll show the process instead of the totals. So we're going to have 100 times 1.0, actually, one plus 0.06 divided by 2. Now that turns out to be $103, but we're just going to leave it at this. Now, for the second year, the second half of the year, what do we start the year with? Start the second half of the year with the amount that's in the second row. So this is what we start with. For the second half of the year. And then what do? We multiply this by 1. Now this is really $103. That $103 got multiplied by 1 plus 0.03, which came from 0.06 divided by 2. But this is really 100 times 1 plus 0.06 divided by 2 raised to the second power. There are 2 of these. Okay, so that's what we end up with if we're just showing the process instead of getting these totals. Now we will predict the expression that represents the total amount after, so let me create a little more space. After $100 is invested at 6% interest, compounded semi-annually for 10 years. Now this is because this was a worksheet that I imported into here. It tries to renumber everything. Okay, so predict the total amount, $100, invested at 6%, compounded semi-annually for 10 years. Type in your answer into your group chat. But don't hit enter yet. So everybody work on this individually. Go ahead and enter it into your group chat. See what others put down. Okay, group 5. What do you got for this?
I said 180.61.
180.61, and how did you get that?
Well, I did 100 times 1 plus 0.03 to the 20th power.
Okay, now if we were predicting the expression, you said 0.03, and that came from taking the 0.06 and dividing it by 2, and you raised it to the what power?
20th.
20th power. How come you didn't raise it to the 10th power? Because it's 10 years.
Well, I don't know. I just thought since it was compounded twice a year. Sorry, I don't know.
Well, I'm challenging you here because I've done this class before, and almost everybody puts a 10 up here for 10 years. But the real correct answer is 20, what you did. And then we wind up giving this. And the reason it's not 10, but it's 20, has to do with, and let me, hang on a second, I'm looking at my own key here. Okay, so when this right here was 1 year, look at, when it was 1 year, I want this in red, when it's 1 year, we get double that up here as the exponent. How come double that? Because inside of 1 year you get 2 compoundings. By the end of 2 years you'd have 4 compoundings. In 3 years you'd have 6 because there's 2 compoundings inside every year. So by the end of 10 years you'd have 20 right here. That is correct. This is the expression that we need. All right, we don't really need this answer because it's really asking just predict the expression that results. And the expression is this part. All right, so let's do it again. Let's call this B. $100 is invested at 6% compounded semi-annually for 15 years. Guess at the expression that you're going to get there. And then when it's compounded quarterly for 1 year. So B and C Okay. Type in your answer to your group chat. Okay, group 4, what did you get for B?
I got $242.73.
What was the expression? How did you come up with
So you get 6% divided by 2 to make it half, and then you would do that to 15th power, I think.
it? And you raise this to the
15th power, and put the 1 in front of it,
Ah,
so it's faster.
so what goes in front of it?
The 1 to make it so it's 1.06, my bad. Divided by 2.
So it's 1.06 divided by 2, like this?
Yeah, to the 15th power.
To the 15th power. Alright, and your name is?
I'm Mushi.
Mushi. Thank you very much for this contribution, Mushi. I really like it when we get intelligent answers that are closely related, but they're common student mistakes. So there's 2 common mistakes that you made here. The real thing is, see, the 1 doesn't get divided by the 2. Only the 0.06. And if you put it this way, the 1 gets divided by the 2. And then, the other thing is, this 15, every year you compounded it twice. At the halfway point, and then at the end. So 15 of those years happening, this 15 gets multiplied by 2. Raised to the 30th power. And then we have the $100 up front. So this would be the expression. This one, I see this a lot, so I'm very glad you put this one. You said something like this, Mushi. Because that's kind of instinctive to go this route. But these little subtle differences make all this 1 plus, and then we gotta go twice that because of the compounding. Okay. And then for part C, let me call on group 6. What do you have for part C?
For C, I got 106.14.
How'd you get to 106.14?
Did 100 times 1 plus 0.06 over 4 to the 4th power.
Over 4 raised to the what power?
4th.
Pardon?
4th, the
To the
4th
4th
power.
power? Okay. Ah, that is it. Okay. So, $100 invested at 6% interest, compounded quarterly. What would be different about this table would be we'd have it at the 1/4 mark, and then you'd get 1/4 of this interest, 0.06 divided by 4. And that would happen though 4 times. That's why it gets raised to the 4th power over here. Alright, so those are concentrating on the expressions that we get in each case. Any questions at this point? Alright, so that was, and it's going to renumber all my stuff. Number 3. Oh no, this would be part DD. Alright. And eliminate this. So $100 invested at 6% interest, compounded quarterly for 20 years. Write the expression that you're going to get for that. Enter it into your group chat. Okay, I'm going to give the answer for this one. $100. All I think about at first is after 1 quarter, that's going to be my total. After 1 quarter of 1 year, I'm going to get that much. And then by the time 1 full year is done, I would have it to the 4th power. By the time 2 years is done, I'd have it to the 8th, because it happens 4 every year. So what goes up here is 20 times 4. 20 times 4 times each year. So it's this raised to that power, to the 80th power. All right. At this point, we're kind of transitioning now. But give me a little feedback on your comfort level with this. Do I need to review this a little more, or are we ready to go on and you feel like you understand this? So, everybody give me a little feedback there. In the main chat. Okay, looks like we're ready to move on. So, the variables, we're going to get to the compound interest formula now. And the variables in the compound interest formula are A for total amount, P, initial principal, how much we invested, R is the interest rate per year. So if it was 5%, you wouldn't write it as 5%, you'd write it as 0.05. The time is T, and it's in years. And very important, this new variable, N, is the number of compoundings in 1 year. If you're compounding quarterly, you'd be compounding it 4 times a year. N is 4. If you're compounding monthly, N is 12. Weekly, N is 52, and daily, N is 365. Now, there's not exactly 52 weeks in a year, not exactly 365 days in a year, because of leap year and so on, but we'll use those for our approximations here. Okay, these are the different variables. All right. Now, when $100 is invested at 6% interest, compounded quarterly for 20 years, we got this expression. And that was exactly the same expression we got over here. There I wrote it as 20 times 4, and here I just put it as 8. The 80 in the exponent position comes from multiplying the n and the t. T is 20 years, and n is 4 when you're compounding quarterly. Replace each number in this equation with a variable from right up above. This should be number 8. When you're done, you'll have constructed the compound interest formula. So you're going to do this expression. You're going to rewrite it, a equals, and you're going to write it with as few numbers as you can. You're going to replace numbers with letters up here. And we do it so you can see both. There's the expression. Start with a equals. Instead of 100, choose one of these letters. And then put the left parentheses. Then put 1 plus instead of the 0.6, choose a letter, and so on. Do that so that you get a compound interest formula. So, I'm going to give you a minute to work on that individually. Okay, enter it into your group chat. Okay, group 2. What do you have?
Is it A equals P times 1 plus R over N to the power of T times N?
A little dot for times. T times N. That is exactly it. That is called the compound interest formula. And we came up with it ourselves from looking at, oh, this is the expression that would come from a real problem, and then we used these variables and we plugged it in. It seems to make sense. That 100 was the original principal. That's the interest rate. That's how many compoundings in 1 year, since we're compounding quarterly, and then we multiplied those two, time and the n. All right, this is the compound interest formula. Now, one of your first tasks is going to be to memorize this formula. Do you need to have it memorized? Yes. So I want you to study it for a little bit, and then turn away from it and write it down from memory. So I'll give you a minute for that. And after you write it from memory, then look back to see if you got it correct. Okay. So we have this little activity here. No interest versus compound interest. And, all right. The parents of a woman born to royalty put $25,000 in a vault for her every year starting at her first birthday. Of course, no interest is earned on money in a vault. The day after her 60th birthday, she goes to the vault and extracts her money. So, how nice it would be to be born into royalty and have $25,000 every year put in a vault for her. By the time she's 60, she's going to be pretty well. Right. And then, so this was really number one. This darn thing renumbers everything for me. Number two, the school teacher's father set aside $10,000 for his son. And the day his son was born, the father purchased a Honda Civic instead of a Ford Explorer, after he'd borrowed the money needed for the Ford Explorer. The $10,000 he saved, he put into the stock market. Now the stock market, since its inception, has an average return of about 10% per year. If you average all the stocks over all the years that they've been in there, it approximately has about a 10% return per year. Well, the son grew up, became a teacher, and retired. At age 60, he cashed in his stocks. The investment had risen and fallen in those 60 years, but its average annual return was 10%. All right, those are the two situations. Now, when both turn 60, will the woman born to royalty have 100 times as much money, 1,000 times as much money? I mean, she's getting $25,000 every year for 60 years, and this was a one-time $10,000. But she earned no interest. He earned 10% interest. All right. We'll answer this by filling in some tables here. So the woman's total. At age 0, it was $0. On her first birthday, she got $25,000. So you fill in, what did she get on her second birthday, third birthday, fourth birthday, jump to 20, 40, 60, and then even put in. So everybody do this first column for the woman's total. I'll give a little bit of time for that. Alright, so all we do here is multiply 25,000 times the number of years. And then 25,000 times 3. $75,000. We can make this go a little bit faster. Putting K, 1,000, so 100K. And then this would be 25,000 times 20, which turns out to be 500,000, 500,000. 25,000. And this turns out to be $1 million. And then 25K times 60. and it's $1,500,000. Wouldn't it be nice to be royalty? And the general formula is 25,000 times n. Now, let's go to the teacher's total. You can see how I computed 1 year's worth of interest. Get these for all of these, all the way down. Okay, well let me have you stop. I'm going to call group 5. What'd you do for age 2?
Hold on one second.
I mean, I think you would pretty much just do the 10,000 times 1.10 to the power of 2 instead of 1.
That's exactly right. Because it's going to take, you could also start with this 11,000 and then multiply it by one more, 1.10. But it's the same as this. And when you do that, you're going to wind up getting $12,100. Now, make sure that you're getting these answers, that you can punch these things out in your calculator. Do at least one of these. Okay, so we're going to keep that pattern going. Now look at, compare these. She's got 75,000. It's only up to 13,000. Just getting clobbered by her savings. And we do it again. So she's going up by about 1,000 a year, or he is. Well, she's going up by 25,000 a year. By the time year 20 comes around, punch this in your calculator. And only 67,000 compared to 500,000. 40 years. Punch this out on the calculator. And we're starting to finally get some big. 452,593. And punch some of these out on your calculator to make sure that you can get these same answers. Now this is finally up there, but well, she's more than twice that. But let's go again. This turns out to be 3,044,800 $816. And the general formula is 10,000 1.10 to the nth power. Alright. What actually happened? By the end of 60 years, he has more than twice as much money as she has. And this, you might start to see why there's a famous, it's been said many times, some people question whether this is authentic or not, but certainly has been in the, it's been talked about a lot, was that Einstein was asked, of all the things you've seen in the world, what is the most amazing thing that you've seen? And supposedly his answer was compound interest. And you put a reasonable amount of money in, invest it over a long period, you have to have a high interest rate. One of the only ways to get this kind of interest rate is to take risk with your money. And when you buy stocks, you are taking risk. I mean, you could wind up purchasing stuff that, the whole stock market goes down, or just an individual stock or group of stocks that you bought went way down, so on. But when you put yourself in to the possibility of this, you have the possibility of really big returns. And learning about this as a young person can be really significant. And if you're taking this course and you're not young, you might still think about such things with people who have a lot of time at their disposal. For instance, when I was learning about this, I was a bit older. But when I had my kids, when they were about, right around 10 years old or so, I had saved up some money, and I gave them a choice of getting that money, or that we invested it in a IRA account. That's an individual retirement account that you get penalized if you take it out before you're age 60. And I showed them how it would grow to a large amount of money if they put it into an IRA account and waited till they're age 60. And both of my boys opted to get it into an IRA account, and then I had lots of time to let it build up. And one of my sons, he's 20 years old now. He's never added to his. My other son, who's 17, he's a saver, and he's added to his money. A couple times he's inserted more money into his IRA account. All right, so the woman earned no interest, while the teacher's son earned compound interest. You can get interest on your interest. Again, here is the variables, here is the compound interest formula. And then here are the problems, and there are solutions, selected solutions. Now these problems, they've been renumbered and stuff, so don't go by what's in this in OneNote. Instead, I want you to look at this assignment in the modules. So when you go in here, in the modules, simple and compound interest, here it is. Simple and compound interest, and then here is the worksheet, and then it's replacing a textbook section. So if you click on this, downloads, and this is the clean version, won't have renumbered stuff. It's all this stuff that we did in class is all here, correctly numbered, and has even the woman versus the teacher, and it has these problems. And this is your homework. To do these problems and then check certain ones where the answers are given. Okay. So, homework.
Do we still have to fill in the things that we did in class, or just ignore?
No, you don't have to. You don't have to. That's just for your information. And you don't even have to fill in those questions. I think you could just write it on a separate sheet of paper and then upload just the answers. Okay. So the homework is this. The last problems are called the student homework problems. And any questions, comments? We will stop here. I'm going to stop the video recording.